Okay, welcome to the next video in the systems programming video series. I believe we just finished writing the decode function, and so we're now moving on to encode. So we're going to edit the encode.c file. We will write a program that reads in a ppm file and ask the user for a message to embed within it. So to make is standard, you pass as a command line argument the ppm file. It prints some information and says that it's writing this file. Should read ppm as command line argument, report usage if no file is given, report an error if the file cannot be read. You should output a new file based on the input name, sure. Reuse your implementation, output size, blah, 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 for debugging, blah, blah, blah. Okay, so I think that's fairly clear. Now we're going to go into the encode file, and you can see here the implementation that I have already given. So I'll just scroll down, let you look at this implementation, but we'll now build it from scratch, except that I won't build this first part from scratch. So we've already checked for the number of command line arguments, and now we're going to right, the user has passed in a file name. We're going to open that file and build its pixel map, reusing the code that we've already written. Oh, by the way, I guess I should remark, this read file that is here in assignment 6 is basically the same as it was in assignment 5. I have copied and pasted my previous solutions to the read function and the write function. So you'll want to make sure to remember to do the same if you were to implement this as well. Okay. But anyway, so I can use my read function and I can call int wh and then struct ppm. I think we've done this in the previous thing, so I don't think this needs too much explanation. So now that we have the pixel map, we would like to traverse through every byte of the pix map, meaning for every, pixel and color, we would like to, oh, right, and we also need to prompt the user for a message that they want to encode. So I guess let's maybe pull up what we should be prompting the user for, which is like we should be telling them how many characters they can use. So, right, so I could go ahead here. I'll just copy all of this, and I think we can go ahead and prompt that right here. So I'll want to say print, give them this message, but this will be a variable. This will be a variable. Here, I'm just going to go back to full screen here. Right, and that's a digit, and that's a digit, and that's a digit, and this is a, oh, right. But that is going to be the end of the first print. So we would like to fill this with our width height, and then they give me a passphrase. Probably I want to get rid of these line breaks, but now I want to scan out, and I need to have a destination, so let's go ahead and say, maybe I'll say unsigned char star message equals malloc size unsigned char times, and I guess I need to figure out how many characters can be saved, so I should probably do that up here, which is to say int max char is w times h times 3 divided by 8. I think I've discussed that logic in the previous video, so maybe I don't need to repeat that here. And then scan, oh, right, I gave it width and height, so I should actually put max char there, and then I need to move that up a line. Okay, right, and so now I am prompting them. I want to receive the message, and I want to print. And here I might want to just go ahead and create the new file name. So let's say, oh, right, yeah. So char star new equals, let's just malloc size of r times, how many, or, yeah, let's say times sterlen of argv1 plus 1 for the null character, and I also want to say plus the additional characters needed to write dash encoded. So what encoded, that seems like 8 letters, so an additional 8 letters. So that's my new file name, writing file %s new file name. Okay, so we've got the pixel map. We've printed info to the user. We've collected info from the user. Oh, I probably need, yeah, I need to give this a format string, so S, I guess. And now we need to go ahead and open up the file at the given file name. So let's go ahead and say file star fp equals f open. I should probably check that all my malloc's work. So if not, message f alloc fail. Okay, so now I want to f open new file name, write binary. If not fp, then printf. So I now have my file open. I want to go ahead and write the header information. In fact, to keep this video short, maybe all that I'll do is, oh, what am I thinking? Sorry. I shouldn't be doing any of this part, because I'm simply going to make a call to my previous function, which is the write ppm or whatever. And so really all I need to do right now is traverse the currently existing pixmap and edit it as needed now that I have the message. So I think I'm going to probably want a byte tracker. So let's say int byte index initialized at 0. I'm also going to want a byte mask so that I can take a given byte, leave almost all its digits the same, but set the very rightmost digit to either a 0 or a 1. And so if I want to set it to a 0, then the strategy is going to be to make a byte of all ones except on the rightmost end it's a 0. If I take that and AND it, bitwise AND it with any byte, then the result will preserve all the bits except the rightmost bit will be forced to be a 0. If I want to force the rightmost bit to be a 1, then I'm going to want to take a byte of all zeros with a rightmost bit of a 1, and then I will bitwise OR it with any byte. Okay, so just so that I can make a simple call to mask each time I need to do this, I'll go ahead and say int, and this might be worth knowing that I am going to use char because I only want this to take up a single byte. Let's call it mask 0. And so this is going to be what I use to zero, right, to assign a 0 somewhere, meaning it's all ones and then a 0. Well, how do I get that, right? Like, what would I put here to get a byte which is all ones and then a 0? Well, if we think about how unsigned binary numbers, what is the unsigned binary number equivalent to that? We could calculate it, but it actually is nice to know that it's just -2. You could just think about how -1 should be the thing right before the discontinuity, right? So the discontinuity for unsigned numbers happens at 0. If you have all zeros, that's the number 0. If you have all zeros and then a 1, that's the number 1, and so on and so on. And as you keep going along in binary, eventually you get to a sequence of all ones, and that is effectively the same as -1, right? As far as an unsigned integer is concerned, a sequence of all ones is basically the same thing as -1, because as soon as you add 1 to it, you get to 0. Well, anyway, so if that's what all ones are, then if I want all ones except the rightmost bit is a 0, then I want to go back from that by 1, meaning that I want -2. And so anyway, -2 is the sequence of all ones, but the rightmost bit is a 0. Okay, continuing with similar ideas, unsigned char mask 1. I want to be all zeros and then followed by a 1, so that's just 1. Now, of course, I want to get into some kind of a loop, but in particular, I especially want to make sure that I use up every character in the message. I'm sure there are other ways to do this, but I'm going to try to design this so that I fundamentally am doing a for loop over the message. Now, for each character, I want to 8 times extract a bit from this character. Here, let's just get started by saying that I want the char C to equal the message at index I, right? So there's my char. That char is 1 byte, and I want to take its binary code and extract each bit and then use its bits to go through 8 different bytes of the pixel map. So, point being that with a given char from the message, I want to do something 8 times. So I'm going to say for int j equal to 0, 8, because it's specifically 8 bits. J++. Okay. Now, what I want to do is I want to grab, let's say, the pixel which is at the byte in the pixel map, which is at the current byte index. And so let's go ahead and say that int, right? So if you tell me a byte index, how do I find my pixel index? I think we've been over this before. It is going to be byte ind divided by 3. And then if I want the RGB index, that is byte ind mod. Now, one other thing I want to do is I want to get the parity of C, right? Because the parity of C is just the same as whether the rightmost bit is a 1 or a 0. So basically, the bit that I want to write into the pixel map is going to be this bit, which is C mod 2. And ultimately what I'm going to do, because that's like the rightmost bit of the char C, and later on I'm going to bit shift C to the right every time I go through this loop so that the bits keep moving to the right so that computing at mod 2 will always deliver me the next bit. Now, depending on what this bit is, I will either mask in the appropriate place a 0 or a 1. So if bit, and just for simplicity, I could go ahead and say that. So that's like if bit is equal to 1 effectively, because it could only be 0 or 1. So this is saying if bit is equal to 1 effectively. And so here I want to take the corresponding place in the pixel map, and I want to put this bit right in the appropriate place in the pixel map. But it is not obvious. I think, it took me a minute. It may take you a minute to think about exactly where is the right place for this bit to go. Because if you say that the right place for this bit to go is at the current byte index, and that would not be correct. Right. In fact, that is a mistake I've been making, that I need to start this off at 7. The byte index should start at 7 because, if you think about like the first 8 bytes starting from index 0 going up to index 7, then this bit here being the rightmost bit of the char C, it should go at byte index 7. So as we progress through the char C, the byte index should progress down from 7 to 6 to so on, all the way to 0. And then once it gets down to 0, it should like pop up to 15, right? 8 plus 7, 15. And go again, right, from 15 down to 14, down to so on, down to 8, and then pop up, again, right? So in any case, right, so the byte index should be initialized to 7 and go down as we do this for loop. Having corrected the byte index, then the byte index is telling me the correct place in the pixel map to try to put this bit, which is to say mask the byte at the byte index. So long story short, we need to get the byte in the pixel map, which is going to be pixmap bracket pix index colors bracket RGB index, and whatever is there, I want to make its rightmost bit a 1 in this case. So that means that I want to OR it with my mask 1. In the else case, I want to take pixmap at pixin.colors be ind, and I want to bitwise and it with mask 0. Now from here, I should decrement my byte index. I should bit shift C to the right by 1. That was the plan all along. Think this should be fine, and then once I get outside the for loop, now if you think about this, what has happened is that byte index, let's just imagine from the beginning, was 7. It decremented 8 times, so now it is equal to -1. If I add 8 to it, it'll go back to 7. That'll put it in a loop, and I don't want that. I want it to progress. So in fact, I need to add 8 and then another 8 to get it up as far as it's supposed to go. So that is to say, what I want to do is I want to take whatever the current byte index is at this point and increment it by 16. Well, okay, this might be the whole thing, so let's go ahead and free anything we malloc, which includes the pixmap. Oh, right, I never wrote this to a file, so that's something I'm missing, which is that we need to write ppm new file name with the pixels as they are now, so I think that would be the pixmap with width and height. And so I think that's that. So that's all that we need to do for writing. So now I free the pixmap, null the pointer, free the message, null the message pointer. Anything else I malloced? New file name, so I should do that too. Should return 0 at the end. That might be it. Let's try it out. So let's say make encode. Doesn't like something. Yeah, maybe the message, maybe I shouldn't declare it as unsigned char, because that might mess up strlen. So let's just say char and see if that fixes it. Yes, okay, that looks good. If I say /in applied to what? Right, and I think I want to test it out on, oh yeah. Yeah, I guess I could test it out on anything. What example do we have? Right, so if we take feepraw and encode it with lol, then I think we should be able to compare it with what's already there. So let's try feepraw. All that printout looks good. Seems to have written. Let's come over. Did something went wrong? Because it says writing file, but then nothing is here. Oh, what am I thinking? Oh shit, I hope I didn't just write over, which I did not. This looks like the original feepraw, so good. So new file name never got anything in it. Oops, yeah, that's right. So I need to make the new file name. I forgot to get around to that. So what I want to do is I want to stir copy into new file name the old file name, but I want to break it up. So I'm going to say stir talk. I think I've done this in the previous videos, so I won't explain it too much. But delimited by dot, and then I want to stir new file name with dash encoded, and that should do it. Okay, that looks better. Anyway, looks like this got created. If I open it, then, oof, that looks good. So it might be hard to see on the screen, but I'm going to open both of these files. One is the original distributed with the project, and the other is what this just created. If they match, then that is a strong sign of success. And this says null. I don't know, that probably this is maybe too faint or too small to see. I don't know. But that says null, and this says null. This says so, S-O-H, and this says so. Okay, I just edited it. But anyway, so they match, right? So to so, D to D, so to so, so to so, null, 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 whatever character this is, and so on. They're a match, so that looks like success. If we now try this all over again with something else, I guess we could maybe try tiny encoded, and if I did 174 exclamation mark line break, do I have to put the line break? Yeah, I probably have to put that explicitly. And if I do, then if I compare tiny encoded with, oh, oops, I encoded the encoded thing, so that's not what I wanted to do. I want to encode just tiny. Something's not working. oops, so dot slash tiny dot p, and I want to do 174 exclamation line break. Oh, that's not going to work because it's going to, yeah, it's going to interpret this, it's going to escape this character, so the line break isn't going to work. I don't know how I would do a line break, but in any case, maybe it's not that important. Maybe if it just represents the 174 well enough, then we'll call it success. So let's open this up. Let's open up the mirror encoded file. Let's compare them against each other. And they are, what's, ooh, well, they're not a perfect match. Oh yeah, they're not a perfect match because of the end, but again, the end isn't going to match because I probably didn't get the line break. So okay, so these, insofar like in the places where they were expected to match, they did match, and so that's a great success. Okay, let's do maybe one more test, this time on this Mona Lisa file. I guess there's also the cat painting, but I'm not, right, like if it passes one more test, I'm going to be convinced that it's correct. So let's maybe try Mona Lisa. Although then I don't know, well, yeah, then I guess I couldn't compare it against the encoded because I don't know what was encoded in, although I guess yeah, whatever. You know what? I'm not going to bother with it. I guess what I could do is I could decode an encoded painting, then take that, find out what message was encoded in it, then perform the encoding with that message, and then, right, like, but it's such a long process. This seems to be working. I'm going to call this good.